Okay, so given all that, I've come up with a couple of alternative ways we could have structured the data. What do you think we should have done?
Before you dive in, I wanted to give you some tips so that you have a foundation for analyzing the different database schema options. First and foremost, when you're making your database schema, you should be clear what you're optimizing for. With Firebase, the first thing that you're trying to optimize for is the amount of data transferred over the network. You want it to be as small as possible. This means that you shouldn't be pulling down tons and tons of data every time the user changes a shopping list item if you don't need or use that data. Of secondary importance is the number of network requests that you make. When you're writing to your database, this means being aware of whether you should use update children or set value. Set value is great for writing data to one location in a database, but if you need to write data to multiple locations in a database, it's better to use update children. For reading, analyzing whether a series of network requests is excessive is a little bit more complicated. Mainly, you want to be aware of how many listeners that you're making. I'll show you an example of how you can tell how many listeners that you're creating. Say that you want to have a screen that shows a user's friends. One way you could organize the data is to have a list of friends' emails for each user. If we had 6 users, there'd be 6 friends' emails listed here. Now, in the UI, it looks like you want to display the name of the user. So what you'd probably end up doing is using the email here as an index into the user's data structure to be able to grab the name. To count listeners, there would be one here to get all of your friends' emails, and then for each friend, you'd have another listener that would then grab their name. If you have 6 friends, that is a grand total of 7 listeners. But there are other alternatives that you could think about. If instead of just storing the email here, you stored the email and the user's name, this means that you would only need one listener to display this data. Another alternative would be trying to cache the user data on the client side. But at the end of the day, what you should really be thinking about is if these extra listeners seem to be affecting the users. If they don't, then you could decide that the data structure is okay the way that it is. But you should always be aware when you might be generating a bunch of overhead by adding tons and tons of extra listeners. My second tip is to think about the future. And we really messed up with this one with Shopping List Plus+, and look where we are now. You should try to think about the parts of your database that are going to get very big. For example, you might ask yourself, how many users am I going to end up with? If the app gets extremely popular, you could end up with millions of users. On the other hand, another thing we store in our app are shopping list items. So you might be wondering, how many shopping list items might we have for a single shopping list? Maybe 10? Certainly the number is unlikely to go over 100. So when you're trying to make a trade-off between a data structure that would divide up the number of users that you need to search through or display on a screen versus one that would optimize for the number of items displayed for a single shopping list, you would probably want to choose one that favors the number of users. Remember, we kind of already did optimize for shopping list items by dividing them up based on the shopping list that they're part of. So at least that was good on us. In tip 1, I clarified what you're optimizing for in general. To apply this specifically to your app, you should be using your activities as guides. And what I mean by that is take all of the activities that are in your app and figure out what information do they need from the database. For each activity, you should be optimizing the database so that it's able to quickly retrieve the exact information that it needs, again, with minimal data transfer and not too many network requests. My next tip is basically to take denormalization to heart. Don't be afraid to have data that seems like it would be related in different parts of the app if it optimizes displaying for one of these activities. Just make sure that you always denormalize with a purpose. A deeply nested database is often a symptom that somewhere in your app you're going to be forced to download a lot of unnecessary data. If you see that you have a many-leveled nest, you should quickly look into whether or not this is actually the case. And of course fix it if it is. But if it's not the case that you're downloading a lot of extra data, then a little nesting can be fine. Alright, with all of those tips in mind, here are some suggestions about how we could have reorganized our data structure had we thought of it earlier. Out of these, check off the ones that you think might have actually helped. In the instructor notes below, I've given detailed explanations about what exactly each of these means and what the data actually looks like. So make sure to take a look at those before you answer anything.